Did you know that the Earth is the only planet in the solar system that supports life? Now, what made life possible on Earth? Well, it's air. Welcome to the lesson all about air. At the end of this lesson, ever imagined what would happen if for some reason air vanishes from the Earth? Well, the birds and insects will not be able to fly. And with no wind blowing, seeds and pollen of plants won't scatter, leading to less variety in plants and trees that grow in a particular area. But most importantly, without air, there could be no life on Earth. Can you guess why? Living beings need air for survival. Plants also use air to prepare food. So, without air, life will cease to exist. The absence of air would mean that windmills wouldn't rotate. So, generating electricity, drawing water from tube wells, or running a flour mill with the aid of a windmill, a major alternative way of generating electricity would become a thing of the past. The absence of air will also mean we would not have yachts, gliders, parachutes, and aeroplanes whizzing past. If someone asked you to get air, where will you go to find it? Well, you needn't go anywhere. Air is present everywhere. In fact, a thin layer of air surrounds the Earth similar to the way the peel surrounds an orange. This thin layer of air is called the atmosphere, and it extends 600 kilometers above the Earth. The atmosphere is dense at the surface of the Earth and becomes thinner and thinner as one moves up. This is the reason why mountaineers carry oxygen cylinders while climbing high mountains. Air is present in every nook and corner of the Earth. But is it present in water? Let's conduct a small experiment and check. Observe the inner surface of the vessel. Can you see the tiny bubbles? Any idea where they are coming from? Well, these bubbles are formed by the air dissolved in water. When we heat water in a container, air starts escaping at 100 degrees Celsius. When this happens rapidly, we say that water is boiling. We just saw that air is present in water as well as on land. But is air present in soil? Let's look at an experiment to find that out. Observe what happens. Can you see the bubbles coming out? When water was poured into the soil, it displaced the air in it. This is why we see so many animals living underground coming up for air during the rainy season. Rainwater seeps into the soil, displacing the air in it. Why does a balloon blow up? Take a look at this experiment. Maybe it will give you the answer. You can see that the water is not entering the bottle. This is because the bottle is filled with air and there is no room for the water to enter. Even if we can't see it, air is present everywhere and it occupies space. Moreover, air takes the shape of its container. Can you see those bubbles? Well, air is escaping from the bottle in the form of bubbles and creating an empty space in the process. water is rushing in to occupy the empty space. Now, to come back to our original question, why does a balloon expand when you blow air into it? As you pump air into the balloon, the air creates space for itself by causing the balloon to expand. In this experiment, you also saw that air is colorless and transparent. This is why the bottle appeared empty, though it was filled with air. We cannot see air, but we can definitely feel it. The rustling of leaves, swaying of clothes hanging on a clothesline, the fluttering of paper are all actions that we see and hear when air flows around. The movement of air is called breeze or wind, depending on its velocity or speed. Can you tell me what is cloth made of? Fiber, right? Can you tell me what air is made of? Let's conduct a small experiment to find the components of air. What do you think will happen next? Will the candle get extinguished? Well, the candle is still burning. Now, burning cannot take place without the presence of oxygen. Hence, we can say that oxygen is a component of air. Hey! The candle is going out. Do you know why? Well, that's because there is very little oxygen left in the air inside the glass. There, the candle has completely extinguished, and water has slowly trickled inside the inverted glass to occupy the space left behind by oxygen. Had you taken 2 glasses of different sizes, the candle in the larger glass would have burned for a longer period, and the water level would have been higher here due to the proportionate increase in the amount of air present in the larger glass. Did you notice that the water did not fill the glass completely? This means that there was another component present in the air that did not support burning. Can you guess what it is? Well, it's nitrogen. Did you notice that there is only a marginal increase in the water level? This proves that nitrogen is the major component of air. In fact, if a pie diagram is used to indicate the components of air, you would notice that nitrogen and oxygen form 99% of it. Can you guess what makes up for the remaining 1%? Take a bottle of cold drink out of the refrigerator and keep it in the open for a while. You will find water droplets on the surface of the bottle. Can you guess the source of these water droplets? Well, it's the water vapor in the air. When air comes in contact with the cold surface, the water vapor condenses and drops of water appear on the surface. The presence of water vapor in the air is responsible for rain and snow. Take a closer look at the beam of sunlight. Can you see something moving around? These are dust particles and are always present in the air. Air is filled with dust particles released from exhaust pipes of cars' smoke, produced due to incomplete burning of fuels, industries, and pollen grains. This leads to the formation of poisonous gases, such nitrogen oxide and carbon dioxide, and smog, acid rain, aerosols, and so on. Smoke and dust particles also harm your body. That is why traffic policemen, miners, and people working in textile and asbestos industries often wear a mask to prevent smoke and dust particles from entering the body. Another way to prevent dust particles from entering your body is by inhaling through your nostrils. Your nostrils are lined with fine hair and mucus that trap dust present in air. So, the next time you inhale through your mouth, remember you are allowing dust particles to enter your body. Have you ever stood near burning material? Did you feel suffocated? Well, you were probably breathing in air that was rich in carbon dioxide. Carbon dioxide gas is also a part of air. However, its quantity is very little. Animals, plants, and humans breathe in oxygen and release carbon dioxide during respiration. On the other hand, plants take in carbon dioxide from the atmosphere and use it to make their food. In the process, they release oxygen. This helps to maintain the delicate balance between carbon dioxide and oxygen. Do you know that the oxygen consumed by plants is less than the oxygen released by them? Hence, we say that plants produce oxygen. Congratulations! You have successfully completed this lesson on all about air. In this lesson, you have learned to identify the properties of air and list its components.